Dear students, in this video tutorial, I will be explaining you about carboxylic acids. So let's see what we should know regarding carboxylic acids. Just you have to know, first of all, of course, its functional group. It's the combination of carbonyl and hydroxyl group, so it's called carboxylic acids, carboxylic group. Also, this is memory based, but make sure to go through these. What are the application areas of carboxylic acids, which is really important. For example, you have to know where do we use acetic acid, or we use pharmaceutical industry, food industry. For example, acetic acid is for making vinegar. Also it's an manufacturing of rubber, etc. Also, please don't forget that we have a few types of nomenclature of carboxylic acids. Whenever you see formic acid, it's a methanoic acid. Whenever you see acetic acid, also know that it's ethanoic acid. Propanoic acid, it doesn't, we didn't give you another name. For butanoic acid, you have to know this is butyric acid. Also, one of the mistakes that student does, whenever I ask you ethanoic acid, some students think like it's C2H5COOH. It's not like that. Ethanoic acid should have in total 2 carbons, but if it is 3 carbons, it's not ethanoic anymore, it is propanoic. So uh, consider this carbon 2 of the functional group. How do we name the carboxylic acids? Remember that carboxylic acids they are highly important acids. They have high priority, and they always locate at the end. So always, whenever you name the carboxylic acid, start from the numbering from the carboxylic acid part, name the longest chain, and just know the branches. One branch is called methyl. For example, in here we have 2 methyl branches. We have to name them 2,2-dimethyl. And some students, they do not include acid in the naming of carboxylic acids. Know that you will lose points if you don't include this acid in the answers. And we have this case. Let's write this case. So whenever we have 2 functional groups, we have carboxylic acid functional group in here, and we have hydroxyl group in here. How do we name it? Always know that carboxylic acid has higher priority than hydroxyl group. Please don't forget that. Always put the carbons to make sure that we know what's the longest chain. And we know that we always need to start from the carboxylic acid. So we start in here, we start in here. We don't stop in here. Remember, parent chain should start with the carbon and should end with the carbon. It should be end terminal carbon. So this is the longest chain. And where should we start numbering? We have to always start numbering from carboxylic acid part. So we have 4 carbons, butanoic acid. And whenever we have hydroxyl group, because this is a stem name, butanoic acid, this is an acid, we have to take it as a branch. So it's this branch, hydroxy branch. Remember, this is not hydroxyl. Hydroxyl is the name of OH, but whenever it's as a branch, we have to omit this L, so it will be 3-hydroxybutanoic acid. Always remember, carboxylic acids are given the highest nomenclature priority. There are practice questions in here. Please work on them and see if you do it correctly. So also, don't forget this caproic acid or goat cheese. We have 1, 2, 3, 4, 5, 6. So we know formic acid, acetic acid, butyric acid, and caproic acid. Please don't forget them. So let's talk about physical properties. Whenever we talk about physical properties, it's about acidity, solubility, and boiling point. First of all, let's discuss about acidity. Whenever you see a word acidity, always you have to consider ionization. Okay, remember the word ionization. Also remember the word mineral acids. Mineral acids, they are HCl, like inorganic acids. And always know that mineral acids, they can fully ionize. They can fully ionize. For example, we have 4 hydrochloric acid in here. All of them can ionize. So we will have 4 hydrogens in the environment and for chlorines after ionization, you see we have lots of hydrogens in the environment. As we have lots of hydrogens in the environment, acidity is stronger. Remember, acidity depends on the number of hydrogen ions in the environment. But if we take these carboxylic acids, this is called regarded as a weak acid. You see, we have a double arrow, means that it is a reversible reaction. It cannot fully ionize. Imagine we have four formic acid in the environment. Maybe only two of them, maybe three of them ionizes. It means that as they cannot fully ionize, the number of hydrogen ions are less. As the number of hydrogen ions are less, acidity is less. So the stronger the ionization, acidity increases. Sometimes we can see the word dissociation, it's the same things, okay? Please don't forget that. And you see always for the ionization of carboxylic acids, we see double arrow, reversible reactions. Also note that once we increase the carbon numbers in carboxylic acids, the acidity should decrease. Just know that it is because of the electron withdrawing power. CH2 group has lesser electron withdrawing power than hydrogen. So CH3COH is weaker than HCOH. So once we have more carbons, the acidity decreases. But if we compare the mineral acids and carboxylic acids, of course, it depends on ionization. Regarding the solubility, let's see, solubility and boiling point, I believe, let's discuss about solubility. Just remember one thing. Solubility, we are discussing about solubility in water. Know that whenever this question is about solubility, you have to know the polarity. And you have to know this thing. Polar molecule dissolves in polar, and know that non-polar molecule dissolves in non-polar molecule. And know that polar cannot dissolve in polar. So basically, like dissolves like. Okay, please don't forget that. Also, you have to know one more thing. We know that carboxylic acids has two parts, yes? One of them is a functional group part, and another is carbon hydrogen part. Note that functional group part is polar part because it contains hydrogen bonding with the water, but the carbon hydrogen part is called also non-polar part. So what's happening? Imagine we are comparing these two molecules, CH3, COOH. What's happening to the polar part? The polar part doesn't change. We have the same COH in both parts. So polarity remains same. But what's happening to the non-polar part? Non-polar part is getting more because we have more carbons and more hydrogens. As the non-polar part gets more, non-polarity becomes more, increases, or let's say increases. As the nonpolarity increases, the molecule becomes more nonpolar. So solubility in water, it's a polar molecule, becomes lesser. So the numbers from methanoic acid to I don't know, it is caproic acid, it decreases. Okay. Also know that valeric acid, 5 carbons, so it should decrease because nonpolarity increases, polarity decreases, and the solubility should decrease from top to bottom. It's in here we have included that hydrocarbon part is hydrophobic. Hydrophobic means it hates water. So because we are increasing this part, hydrophobic part, it becomes less attractive to the water, so the solubility decreases. Regarding the boiling point, you have to know one thing is that boiling point depends on, whenever you see a question of boiling point or melting point, it depends on intermolecular forces. We have three types of intermolecular forces. We have learned hydrogen, dipole-dipole, van der Waals or London dispersion forces. Just know that between two carboxylic acids, we have two hydrogen bonding. Because of these hydrogen bonding in carboxylic acids, it is quite stronger. Hydrogen bonding is the strongest type. So it is quite difficult to break carboxylic acids. That's why carboxylic acids, if we compare them with the alcohols or alkanes, etc., with the similar, approximately similar masses, they always have higher boiling points because of the two hydrogen bondings. Also, hydrogen bonding is stronger, so it really doesn't much depend on the masses. So whenever we have hydrogen bonding, the boiling point is higher. Also, we see it in here that between two alcohols, we have one hydrogen bonding, so it is weaker than carboxylic acids. Also know that boiling point too. If you see the boiling point, it increases once we go from bottom to top. The order is the same from top to bottom, but we have two exceptions in here. You see, actually, the boiling point is increases from propanoic acid and caproic acid, but as we see, formic acid and acetic acids, they are more than the others. So this is out of trend actually. Why? Because of the formic acid, because of the hydrogen bonding. We know that in formic acid we have only one hydrogen, and so basically nonpolar part, the hydrogen carbon part is less. So as it has a formic hydrogen, stronger hydrogen bonding, it is harder to melt it. It's harder to melt this molecule. Also for acetic acid, it's the addition of CH3. It's again the area, the hydrogen bonding. So it is a bit difficult to melt it. Only the exceptions are these two, but once we go from top to bottom, the number should increase, increase in a usual order. These two are the exceptions. Also, we have few other exceptions too. Just know that, especially remember these two, formic acid and acetic acid exceptions. But for others, the thing is that it should increase and increase and increase once we go from lower carbon to higher carbon. Also, what else for? But for boiling point, the trend is always in upward position. Again, we might have an exceptions, but usually the trend is that we will not ask you the exceptions. But from a melting point, remember only the formic acid and acetic acid exceptions. For the others, we will not ask you any other exceptions. Thank you for listening, and wish you all the best.